So hardware and von Neumann architecture, these are the two types of architectures we are having for microcontroller. First one is the hardware architecture. Now at the center point, at the core, you are having a CPU, central processing unit, which is actually performing the computation. Now for performing a computation, you need an instruction or you need the data to execute that instruction. Simply, when you are executing a C program or Java program, that program is stored somewhere in the memory. Fine. So one by one, the CPU will fetch the instruction and it will execute. Isn't it? That this basic thing clear? And while computing, it may see now there is a difference between instruction and the data. When you are executing a C program or Java program, if you come across the line C is equal to A plus B, then that line is the instruction which you are executing. But for execution of that line, what you need is the data. Which kind of data you need? You need the values of A and B, isn't it? So that is the difference between that is the difference between data and the instruction. So for the execution of C is equal to A plus B, what you need is the value of A and value of B. Now from where you will get these values? You will get these values from the memory, isn't it? Then you will perform the computation and the result will be stored in the C. So what is C? C is nothing but certain 2 bytes of the memory which has been allocated and it has been named as C, isn't it? So again, it means what? You need to store that result in the memory. Fine. So C is equal to A plus B is the instruction. Value of A and B is the data. Generated result is again a data. And where you are having your data? In the memory. So you will retrieve the value of A and B from the memory and result will be stored again to the memory. So how the communication will go? By using a data bus and the address bus. If you want to carry the data, then you will use the data bus. If you want to carry the address, then the address bus will be used. So CPU, if the CPU is referring to certain address of the memory, then that will be carried by address. If the CPU is carrying a data, it wants to store the data, then it will use the data bus. Now, if you observe, RAM is the volatile. Volatile means what? The data will be lost when the power is off. Clear? So, address bus is unidirectional from the CPU to the data memory only, because from data memory, the addresses will not move to the CPU. From the memory, what will go? From the RAM, what will go to the CPU is only the data. So data bus is bidirectional. That means what? CPU can store the data to RAM and it can store the data to RAM and it can access the data from the RAM. So that's why it is a bidirectional. Clear? Means what? The data can be stored from the CPU to the data and to the memory. Sorry. Just a minute. So this is what is your address bus, data bus with the RAM. With the ROM, again the address bus is unidirectional only from CPU to ROM. Now ROM is a non-volatile memory, so data will be stored permanently. And data bus, again it is only from ROM to CPU. Fine. So that is what is the architecture diagrammatically, it has been shown how the hardware architecture is. Now see, many microcontrollers use this architecture, including microchip, PICs, the Intel 8051 and descendants, and the ARM9. So the 8051, you must have heard about it, clear? So these are the families of microcontroller. 8051 is one of the family of the microcontroller which is using this particular hardware architecture. Now the volatile and non-volatile. Volatile means the data, non-volatile means the program memories. So volatile, you can refer it as a data memory. Non-volatile, you can refer it as a program memory. Again, I will tell you why it is like this. Now see, volatile means what? The data will be lost as soon as the power is off. So what kind of data you can store in the volatile? You can store only the temporary computations. Clear? You cannot store any specific program or whatever are the important things, that you cannot store it in the RAM. Like operating system is a software, clear? So that you cannot store it in the RAM, clear? Why? Because as soon as the power is off, everything will go. So that cannot be stored. So where it will go? It will go into the non-volatile memory. Even whatever the programs, so that is about the software. So, sorry, that is about the system software. Clear? OS is a system software. So which we want it to retain, so that you cannot load into the RAM, so that you have to load into the ROM. So that is about the system software. If you talk about the application software, whatever the applications you are using, right from your Word, Word, Excel, PowerPoint, up to your C, Java, whatever you are using, the programming languages, Python, whatever. So these programs, again, whatever, whenever you are writing a program and you are storing it, obviously it should go to non-volatile memory, because whenever next time we want to refer, we get it. It means what? It's there in the non-volatile memory. Clear? So that's why it is called as a non-volatile memory, is called as a program memory. Why? Because you are going to store your programs in that. So that can be your application program or it can be your system software. So that's why it is called. So then what you are having in the RAM? What you are having in the RAM? In a RAM, you can get that program temporarily. Clear? But see, your main memory is volatile. So it is a subset of your secondary memory, right? So whenever you want to execute anything, you will get it into the main memory, but it does not mean that you are permanently storing it over there. So basically understand the difference between RAM, ROM, and which kind of data you will store it in the RAM, which kind of data you will store it in the ROM. So these are the memories are treated as a separate systems, each with its own address and data bus. So dono ka address bus, data bus is different. So what are the principal advantages of this? Its efficiency is quite good. It allows the simultaneous access to the program and data memories. Now, why it can access the simultaneous access to program and data? What do you mean by simultaneous access? Now, CPU is performing certain, like CPU is executing something. So it wants the instruction also and it wants the data also. So what it can do, it is having a different data bus to access a volatile memory, and it has a separate address and data bus to access the non-volatile memory. So in one cycle or in a single time point, it can fetch both at the same time. Why? Because it is having a separate address and data buses. So at the same time point, it can access instruction also and it can access the data also. Clear? Because it is having a two different like the buses are separate for both the memories. For instance, CPU can read an operand from the data memory at the same time as it reads the next instruction from the program memory, isn't it? So from the program memory, it will fetch the instruction. Now, understand it carefully. Program memory. So these words can be used interchangeably. Volatile memory, non-volatile memory, data memory, program memory. So you should be able to correlate these things, isn't it? So understand very well why it is called as data memory, why it is called as program memory. Clear? So CPU can execute the CPU can fetch the instruction, the next instruction from the program memory. At the same time, it can fetch the instruction from the fetch the data from the data memory. Why? Because it is having a two different buses. Then the next is the two systems can be separately optimized. For example, the PIC16 has a data. PIC16 is what? It is a one family of your microcontroller. So it has a data memory with an 8-bit data bus and a 9-bit address bus. So what do you mean by 8-bit data bus? It means what? That bus, basically what is bus? Bus is nothing but a carrier. So it is a wire which is carrying your data. So why it is called as 8-bit data bus? Because at a single time point, it can carry 8 bits of the data. Clear? And if when you are talking about the address bus, it can carry 9 bits. But it is true for what? It is true for PIC16. So family to family, this might change. So you cannot be sticky that when we are talking about a microcontroller, it is a 8-bit data bus, 9-bit address bus. No, it is given about the PIC16. We don't know about other microcontrollers. Clear? So every family of microcontroller may differ in the certain of these properties, characteristics. Clear? So this is specifically given for PIC16. Others might be having, might not be having. Clear? So 8051, then 8051, 8086. These are the different families of your microcontroller, and each family is having a different characteristics. So even when you are selecting your components for your project, suppose if you go for performing embedded or IoT project, then in that case you need to understand the characteristic of that microcontroller and its compatibility with other components, isn't it? Because every family of the microcontroller has the different characteristics. It may differ in the architecture, it may differ in the properties, and so on. Clear? So you have to check for the properties or the characteristics of the microcontroller. So on the other hand, the program memory is of 14 bits wide. Means what? Whenever it is carrying a instruction from the program memory at a single time point, it can carry 14 bits. Clear? So that each word holds the complete instruction. Each word means what? At a single time point, whatever it is carrying, that is called as one word. So each word, that means one word, can hold a complete instruction. Why? Because it is 14 bits wide. So almost with that 14 bits, the entire instruction can be carried at a single time point with a 13-bit address bus. So these are the properties given which you should remember. Then the next, what are the disadvantages of hardware architecture? Constant data, often lookup tables, must be stored in the program memory because it is non-volatile. Now see, constant data must be stored. So in the program memory, whatever are the constants that you must be stored in the non-volatile memory. So it will take a more space, because this whichever is a constant data means what, whose value is not going to change, it has to be kept in the non-volatile memory. This means that the constants cannot be read in the same way as a volatile values from the data memory. So constant values, again it has to be referred from the program memory, and other data has to be referred from the program data memory. Clear? So these are the disadvantages. So that is all about your Harvard architecture. Now next is the von Neumann architecture. Now see the diagram. Here you are having a CPU and you are having only one address bus and data bus. Data bus is bidirectional because CPU can also send data to the memory, or memory also can send data to the CPU. So this is a bidirectional, and address bus is unidirectional. Now here for RAM, ROM, and for single memory space, you don't have two different buses. So at a time, you can either read the instruction in one cycle at a single time point. Either you can, suppose the CPU wants to fetch from the memory, then either it can fetch the instruction or it can fetch the data, because you are having only single address bus, single data bus. So either at a given time point, either it can access RAM or it can access ROM. Clear? Not both the things. So instruction and data cannot be fetched at the single time point. So single memory space is what, it's a memory space given for certain kind of tasks. So there is only a single memory system in von Neumann or Princeton architecture. Von Neumann, or also it is called as Princeton architecture. This means that only one set of addresses covers both the volatile and non-volatile memories. The memory map, which shows the addresses at which each type of memory is located, becomes particularly important. Now, the architecture is intrinsically less efficient because several memory cycles may be needed to extract the full instruction from the memory. So of course, at a one given time point, you cannot fetch the data and instruction. So obviously the number of cycles to execute a single instruction, and so to execute the entire program, will be obviously more than your Harvard architecture, because the number of cycles to fetch the program and to fetch the instruction and to fetch the data will be more. So however, the system is simpler and there is no difference between access to constant and variable data. So there is the same way you will access the constants as you are accessing the data. So there is no difference, which was there in the Harvard architecture. But here there is no difference. You will access in the same way. Microcontrollers with the von Neumann architecture include MSP 430. So MSP 430 uses this von Neumann architecture. So that is all about the kinds of architectures that the microcontroller can have. So are you all clear? Anybody has any doubt? Anybody has any doubt?
No, ma'am.
Okay. Next is the software. Now see, as we have discussed again and again, I think in every lecture I am telling you ki what is embedded. There is a difference between embedded and embedded devices and electronic devices. Now what is the difference? Can any one of you tell me between embedded devices and electronic devices? What is the difference? Anyone?
Software.
Yes.
Ma'am, software na, because we encode software in the microcontroller to do a specific task.
Yes. So that is the difference between your embedded and the electronics. See, electronics like your fan. Again, every lecture I'm giving you the example. Like your fan, it's not an embedded. It's a purely electronic device. So there is a difference between embedded and purely electronics device. Purely electronic devices works only on the current. As soon as you switch on the current, it will start working. Of course, embedded systems also requires the current, but it simply does not work on that. It needs what? It needs a program. Clear? And it follows certain programs, certain instructions. Fine. So that is the difference. So now, obviously, when we are talking about an embedded system, then the way how we are discussing about the hardware, we have to discuss about the software also. So now the first chapter, like in the again in the third chapter, we will discuss more in detail, like how to write the instructions, how to write a program, that we will see it in the third chapter. But the first chapter is covering entire basic things, all the basic things, like little bit about your what is embedded, what are the characteristics, what are the areas of application, and so on. Then we have seen the architecture of the microcontroller, what is microcontroller, microprocessor, what is the difference in that. So we are touching each and every area. So again, about the software, we will just have a fast lookup on the software. But again, how to write a program for microcontroller in detail, that we will discuss in the third chapter. Fine. So first chapter is the overall idea about the maximum parts of your embedded. Clear? So second chapter onwards, whatever we will do it in the depth. So right now, it is just an overview of the software. So desktop computers often spend considerable time on the calculations, whether it is analyzing the data or computing the next view in the game. The CPU in a microcontroller spends much of its time interacting with a peripheral. Peripheral means what? Input output devices. So whenever CPU is executing any program, it has to interact with the input output devices. Now, although it may have to perform some calculations on the values received from a sensor, so it has to, like I had given you the example, 2 3 examples I had given you. So whenever we are talking about the embedded, it may accept the data or receive the data from the sensor and then perform the calculation on that data. So like as an example, I had given you the example of temperature sensor or humidity sensor. So it will accept the real-time data with the help of these sensors, and then it will perform the calculation on that, or it may take a action depending on the real-time values. Now, several languages may be used for programming a small microcontroller. Now, for doing all this, see, you are having a microcontroller, you are connecting sensor to that and alarm to that. Suppose as an example, so say, like if you are using a temperature sensor, so that will be your input device. Temperature sensor will be your input device, clear? And alarm will be your output device. So what the microcontroller has to do, obviously we are going to load a program in a microcontroller. So which kind of program you may load in that is, you will read the data real time. Now what is the task of temperature sensor? It will read the value, real time value, like it will read the temperature, current temperature. Now whatever it has been sensed, clear, whatever has been accepted or sensed by the sensor. Just a minute, huh? Just a minute, huh? Okay, so whatever it has been sensed by the sensor, what it will do, it will send that data to the microcontroller. To the microcontroller means what? Obviously, what you have in the microcontroller is the program. So it means what? That value will go to the program. So you may take certain variable and you may store that value in certain variable. Now, of course, you want to take a action for certain condition and you don't want to take a action for the certain condition. So obviously what you have to do, you have to check the value. So obviously you will use the if, you will check the condition with the if, and then depending on the conditions, depending on the condition whether it is true or false, depending on that you will take a certain action. If the condition is true, then the certain steps will be taken. If the condition is false, then in the else part certain steps will be taken. So obviously, and then so suppose if the temperature is beyond the limit, then you will check the value. If whatever has been sensed by the sensor is equal to sorry, is less than equal to or is greater than equal to so and so, that you will have your own threshold. You will check that and you will take a certain action. So if it is beyond a threshold, then what you want to do, you want to make an alarm. Okay, you want to make an alarm. So you have connected an alarm to microcontroller. So what you want alarm or that buzzer should blow. Clear? So accordingly you will send a signal to the alarm and it will start ringing. Is that clear to you? So to your microcontroller, as I told you, ki there are ports, input output ports. So in the second chapter, we will start studying about MSP 430. Each and every pin we will discuss of MSP 430. So that time it will be more clear. But as you know, ki there are ports. There are ports, matlab there are different pins to which you can connect the input output devices. Clear? So that is how. So it means what? See, this is your embedded. So for that you need a software. Clear? So there are different languages which you can use for programming a embedded system. So first one is the machine code. It is a binary data that the processor itself understands. So when you are writing in the machine code, it is purely a binary data and which will be understood by processor. Each instruction has a binary value called as opcode. Each instruction has a binary value. So instruction has a binary value and that we will call it as a opcode. It is unrecognizable to humans unless you spend a very long time on low level debugging. So whatever writing a program in an machine code, writing a program in a binary is very difficult. You have to study it for a very long time and then only you will understand. Whatever, see, C or Java, that these are high level. C is the middle level, Java is a high level language. So in that directly you are writing these thing in these programming languages, you are writing your code directly in English. Clear? Even if you are using a function, you are writing a printf. So printf, you are writing it. So these things are understandable by you as an programmer, but machine does not understand this. Even if you are writing an assembly, even if you are writing an instruction in assembly, mov move, or even if you are writing an instruction add, but that is not understandable. Like it is close to the machine language, but it is not purely a machine language. Purely machine language is purely binary, nothing apart from zeros and ones. You cannot see anything. Is that clear? So the very much close, or that is the machine code. After machine code, what comes is your assembly. So assembly is more close to the machine code, but it's not a machine code. Understand? Clear? So assembly language is little more than a machine code, which is translated into English. Like you are writing an instruction ADD, or you are writing an instruction MOV. So likewise, there are a number of instructions in the assembly. You have to write down those instructions, but again those instructions are in the English, so are written as a words called as mnemonics. So these instructions you are writing as a English word, and that you will call it as a mnemonics rather than binary values. And a program called an assembler translates the mnemonics into the machine code. So whatever the program you are writing, whatever the instructions you are writing, that is called as the mnemonics, and the assembler translates these mnemonics into the machine code. Machine code means purely zeros and ones, purely binary. Clear? So C, Java, these languages, high level languages, uses compiler. Assembly language uses assembler, isn't it, for converting your program into the machine understandable language. So it does a little more than direct translation, but not a lot. Nothing like a compiler for a high level language. So compiler का task is more than your assembler. Clear? Assembler का task कम है than your compiler, क्योंकि कंपाइलर को व्हाट इज अ फंक्शन, फिर वो लाइब्रेरी में से जाके वो फंक्शन का डेफिनेशन के अकॉर्डिंगली उसको चेंज मतलब ट्रांसलेट करना, एंड सो ऑन, दैट ऑल थिंग्स हैव हैज टू बी डन. क्लियर? which are not there in your assembly. Fine. Now a major disadvantage of assembly language is that it is intimately tied to a processor and therefore different for each architecture. So instructions, assembly instructions are different for different processors, because architecture of the different processors are different, and assembly language directly refers to the it is very much close to your processor. So depending on the architecture, your instructions may change, which is not the case at the high level programming languages. Now, most programming of small microcontrollers was done in the assembly language until recently, despite these problems, mainly because the compilers for C produces a less efficient code. Now, the compilers are better, and modern processors are designed with the compilers in mind. So the assembly language has been pushed to the fringes. So nowadays majorly we will be using the C. तो अभी हम लोग भी जो कोडिंग में यूज करेंगे, we will not be using assembly language. We will be using C language. Isn't it? Embedded C we will be using for practicals. So the few operations, notably bitwise rotation. Now what is this bitwise rotation and so on, that you will come to know as we will proceed in the further chapters. Bitwise rotation means what? At a single time you will keep on shifting one bit. So that is a bitwise rotation, cannot be written directly in C. So these kind of things, shifting of bits, that cannot be done in C, and for this assembly language may be much more efficient. So whenever you want to perform such kind of operations, that time assembly will be more efficient. However, the main argument for learning assembly language is for debugging. So assembly language, you can learn it for the debugging purpose. Then disassembly is the opposite process to assembly, the translation of machine code to assembly language. So the reverse process is called as disassembly. Okay. So that is all about your machine code and assembly language. Now next is the C. Now for C, C++, I think I need not have to explain you much. You must be knowing everything about it. You must have done the coding in that also. C and C++, so I need not have to explain much. I'll just go through. This is the most common choice for small microcontrollers. A compiler translates a C into a machine code that the CPU can process. So you know, whenever you are writing a C program, you have to first compile it and then you can run it. So Alt F9, Control F9, you must have done. So this brings all the power of high level languages, data structures, functions, type checking, and so on. But C can usually be compiled into efficient code. So whenever you are using a high level languages, these all concepts will come: data structures, functions, type checking in the sense what? Data type. So all these things will come when you are using a high level languages. Compilation used to go through assembly language, but this is now less common, and the compiler produce a machine code directly. So directly the compiler, what it will produce, it will directly produce a machine code. In between assembly code it will not generate, but directly it will generate the machine code. Disassembler must then be used if you wish to review the assembly language. So you can use the disassembler if you want to view the assembly language code for a particular, for that converted code. The next is the C++, and this is an object oriented language used for larger devices. This, you know, restricted set can be used for small microcontrollers, but some features of C++ are nutritious for producing highly inefficient code. So embedded C++ is a subset of the language intended for the embedded systems. So like how you are having an embedded C, now as we will do the first practical, you will come to know how we are, or when we will go to the third chapter, that time you will come to know about how to write down the program. What is the difference between C and embedded C? Like your for loop, your void main, these all things will remain same. Syntactically it will remain same, but we have got some additional features, or you can say additional functions for handling microcontroller. Otherwise syntactically your embedded C is same as that of your C. So how you are writing a loop? For in a bracket I is equal to 0, I is less than 5, I plus plus, then opening a opening closing of the curly braces. So if then semicolon at the end of every statement, everything will remain same. So syntactically it is same. Only thing is that we have got the additional functions for dealing with the microcontroller. So Java is another object-oriented language, but it is interpreted rather than compiled. So Java so there are compilers, assemblers, interpreters. So Java is more interpreted than your compiler and needs a much more powerful processor. Now basic is, again it was one of the language. Now we now almost nobody is using that, but again it was available for few processors of parallax stamp is a well-known example. So parallax stamp is again a processor for which this language was used. So the usual basic language is extended with the special instructions, so to drive the peripheral. So same way, like normal C is used for programming the microcontroller by calling it as an embedded C, but with the additional instruction or additional functions. So the same way, same is the case for basic. Then this enables the program to be developed very rapidly without detailed understanding of the peripheral. So for programming with the basic, you need not have to much go into the depth of the device or the peripheral. Without going into the depth also, you could be able to write down the program. And the disadvantage disadvantages are that the code often runs very slowly and the hardware is expensive if it includes the interpreter. So that is what is the disadvantages. So that completes your chapter 1. Now the second chapter is purely about the instrument MSP 430. So in the second chapter now, see, first chapter was the overall about your embedded. Second chapter purely we will discuss about the MSP 430. Now throughout second chapter onwards till the end of your till your last chapter, now specifically we will discuss about the MSP 430 microcontroller. Now why we are you studying about this microcontroller only? Because nowadays whatever the Raspberry Pi kits and so on, whatever you are using, those are having this particular microcontroller, and that's why we are studying about this microcontroller. Fine. So in the second chapter, we are going to see about this microcontroller, the pin structure and so on, the hardware part. And the third chapter, we are going to see what are the functions that can be used, or the software part, how to program and so on. And after that your unit 1 will complete. So see, the arrangement is done so nicely that the first chapter is the overall uh, idea about the embedded, then second chapter is your about your hardware part of the MSP 430, actual MSP 430, and third chapter is like this is your pin structure. We will discuss about the pins, what are the tasks of those pins and so on. So then we will discuss about the memory of MSP 430, specifically MSP 430. Then we will discuss about the CPU, how the CPU and what are the functions of the CPU. Memory mapped input output, clock generator, what is a clock, how the clock is important, how the clock is required, how it works. So what are the exceptions, reset, all these things we will discuss, like the internally how is your MSP 430, that we will discuss. And then unit in the third chapter we will discuss about the how to write a program. Fine. And so that will complete your first chapter, first unit. And then second unit onwards we will keep on discussing specifically about specifically about the timer. One chapter is there specifically about the input output devices, we will discuss about that, and so on. So एक function को लेके we will discuss from the unit 2 onwards. Clear? So once we will complete with the first unit, then we can move on to the practical. This is the way now we will do it. So second chapter, we will start with the second chapter, but before that, till now, whatever we are doing, anybody has any doubt in that? Yes, embedded devices are designed for a single task. So till now, whatever we have completed, are you all clear with that? First chapter is over. We are moving on to the second chapter. Any doubt?
No, ma'am.
Okay, how you are finding embedded now? Is it fine? You are getting the things?
Yes, yes.
Okay. Moving on to the second chapter. Now see, this chapter provides a review of most important aspects of the hardware of MSP 430. So whenever you are talking about any microcontroller, the first thing that you must study is its pin out. You must first study about the pin out. क्योंकि जब तुम लोग माइक्रो कंट्रोलर लोगे and when you will start connecting your devices, so first you should know the pin configuration, or what all properties or what all functions of individual pins are there, that you should know. Each and every pin has a specific function. So basically, I hope you must be knowing the microcontroller, right? Microcontrollers are available in the form of IC. It is available in the form of chip. So majority of you must have seen the chip, I think. Yes, last time you had told me. Fine. Yes or no? Anybody wants to see the pic of IC? कोई ऐसा है कि जिसने IC देखा ही नहीं है? Tell me if you have not seen, I will show you. Otherwise, I will move on. Anybody of you, like what is IC या फिर chip? ब्लैक कलर का होता है एंड लाइक सिलिकॉन मटेरियल से इट हैज बीन मैन्युफैक्चर्ड एंड on both the side of that you will be having the pins. So anybody wants to see कि IC दिखने में होता कैसे है, or should I proceed?
मैम दिखा दो ना.
Okay. See, can you see this?
Yes.
This is called as IC. IC or chip. तो कैन यू सी दिस पिंस? एक 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 पिंस है, एंड जैसे ये साइड में है वैसे बैक साइड में भी है. ठीक है, सी दिस. कैन यू सी दिस? On the left side also, on the right side also, it has having a pins. And can you see the numbers written over there, like HCF4016BE? So what is that? That is the IC number. So when you will take a MSP 430, you will find that कि ऊपर ऐसे लिखा रहेगा MSP 430. Is that clear to you?
Yes, ma'am.
Can you see this now? So these are all ICs. Now this like the first pin, always how you can see which is the first pin. See, on the one side you are having like curve like this. See, on the second side you don't have any curve. Getting it? So whenever you are having a curve, you keep it in your hand, and left side of the curve is the first pin. Clear? So this you can call it as a first pin, not this one. Clear? Ye curve hai. This is your first pin, and you can start keep on counting like this: 1 2 3 4 5 6 7 8 9. Clear? You can keep on counting like this till end. So once you complete counting this much, say suppose if this is these are 20 pins, so if you complete this is a 20, then from this side, जैसे यहाँ पे pin है वैसे यहाँ back side also you are having a pin. So that is your 21 22 23 24 25 26. Like this side also you will have the 40 pins. So this pin is the 40th one, the last one, this one. See, this pin is the 40th pin. Are you getting it? So likewise, you will be having the pins on both the sides, and whatever is the curve given, that is the symbol you can remember from the left side of which you can start counting the pin number. Fine. So now this is called as the IC. This is the IC. So microcontroller is available in the form of IC or the chip. This is called as IC or chip. So I think you must have studied about the gates. AND gate, OR gate, NOT gate. So gates are also available in the form of IC. So you cannot say that every IC is a microcontroller. It can be your gate also. It can be your timer also. Clear? So all these things, timers, gates, microcontrollers, all these are available in the form of IC. Are you all clear? And you will find that the number written over there on that IC as I have shown you. Clear? So whenever it has been written MSP 430, you can find that it's a microcontroller. जैसे AND गेट का अगर IC है तो there is a number associated with that. You can just check out. So 74LS08. See this 74LS08. So that is the number of AND gate. So you can use it as a AND gate, isn't it? See this. Likewise, the number will be written 7400N. Likewise, 74LS. Likewise, the number will be written so that you can find that this is your AND gate. Clear? Now, for AND gate, what is the number given? 74LS02. Clear? So, see. 74LS02. So pin number 1, 2, 3, 4, 5, 6, 7. Then from this side down side 8, 9, 10 up to 14. See this. Are you clear? See, this is your curve, and from the left of the curve you will start from the pin number 1, 2, 3, 4, 5. That is what is I have told you. Are you getting it? So ये जो लिखा है 4075, that will be written on the IC. So is it clear? So that is your about the gate. Clear? So from the number you can find out whether it is a gate, whether it is a microcontroller, or what it is. So are you clear with this?
Yes.
Okay. So now see this. That is what is the diagram given over here, which we have to study. So outside view, first in the first topic we will study about the outside view. So this is your outside view. Like see at the top view. तो टॉप व्यू में यहाँ पे कर्व होगा, कर्व के लेफ्ट साइड से 1, ये जो लिखा है ना 1 2 3 4 5 6 7. So your MSP 430 microcontroller is of 14 pin IC. So there are some microcontrollers which are 14 pin ICs. There are some microcontroller which are 20 pins ICs. Some microcontrollers are 40 pin ICs. So MSP 430 has a 14 pins, 7 on the left side, 7 on the right side. So this is the top view. Here you will find a curve, and curve के left side से pin number 1 2 3 4 5 6 7 and then 8 9 10 11 12 13 14. Clear? Now this is the pin, and pin के left side में like 1 is the pin number, and उसके बाजू में what is written is the VCC. So VCC is the function of that pin. ठीक है? Then for pin number 2, what has been written is P 1.0, PACLK, ACLK, A0. So these are 1 2 3 4 4 functions are there. Pin 2 के कितने functions है? 4 functions है. So each function is segregated by a slash. So P 1.0 is a function. उसका कुछ तो meaning है. Slash TACLK. TACLK is some other function. There is some meaning. TACLK, this pin can be used as an TACLK, or it can be used as an ACLK, or it can be used as an A0. So these are 4 functions that can be performed by this particular pin. तो वैसे ही सारे pins के functions have been given to you. So one by one we have to study कि हर एक pin का क्या क्या function है and what is the meaning of that. What do you mean by P1.0? What is the meaning of TACLK? What is the meaning of ACLK? Then left hand side pin number 12 अगर देखोगे X out P2.7. Clear? If pin number 10, if you see RST, NMI, SBW, so there are 3 functions of that. So what do you mean by all these things? So that is what is we are going to study one by one. So this is your outside view. Once we have done outside view, then we have to see the functional block diagram or the inside view. So inside, how is the arrangement done? As we have discussed कि nowadays we are having a microcontroller on chip memory, isn't it? All the things are on chip, मतलब एक ही chip में, एक ही IC में memory is there, everything is there in one chip. तो ये one chip में internally arrangement कैसे किया है? Clear? ये फ्लैश है, रैम है, then port 1, port 2, then you are having a watchdog timer. So we will see about each and everything in detail in the inside view. First we will see about the outside view, then we will see about the inside view, and then one by one we will discuss about the memory and so on. So till this part, are you all clear? I think pin about the pin discussion we will start the next time. Fine.
Okay, ma'am.
But till now अभी हम लोगों को करना क्या है? Second chapter में what we are going to study? What is a microcontroller? What is a pin? How it looks like? Everything is clear to you? Are you all clear with this?
Yes, ma'am.
Okay. So we will stop for the day. Next time we will continue with the pin layout.
Okay.